Supply chain disruption, titanium shortage, production halted. Why? China is preparing to tighten its grip on one of the most critical materials in modern industry, titanium. If Beijing moves forward with a full-scale export ban, it could cripple Western industries, bringing aerospace, defense, and, most dangerously, the robotics sector to a grinding halt. Right now, titanium is a cornerstone of high-tech manufacturing, used in everything from fighter jets to surgical implants. But Western reliance on China for this resource has put entire industries in a dangerous chokehold. Beijing has already weaponized its control over rare earth minerals, cutting off supplies to the West as a countermeasure to trade restrictions. If titanium follows, the consequences will be far worse. How bad could it get? Let's break it down. But first, if titanium vanishes from Western supply chains, which industries collapse first? Keep watching. Titanium isn't just another metal. It's stronger than steel, lighter than aluminum, and resistant to corrosion. That's why it's an irreplaceable component in some of the most advanced technologies in the world. Defense. The F-35 fighter jet, already a financial black hole for the Pentagon, relies on hundreds of titanium components. The U.S. Navy's submarines. Titanium hulls. Spacecraft, missiles, body armor. Cutting off titanium would paralyze Western military manufacturing. Robotics. Here's the problem. Titanium is the skeleton of high-end industrial robots. Without it, companies like Boston Dynamics, Tesla, and ABB would face crippling delays and skyrocketing costs. The dream of reshoring Western manufacturing, bringing factories back home with automated workforces, collapses overnight. But is this just a hypothetical scenario? Or is China already laying the groundwork for a ban? That's where things get even more interesting. Automation is supposed to be the West's solution to labor shortages and rising wages. But there's a catch. Without titanium, building industrial robots becomes a logistical nightmare. A single robotic arm used in automobile assembly lines requires high-strength, lightweight materials, and titanium is the best option. If China shuts off exports, the West faces a crisis on two fronts. No titanium means no robots. No robots mean no future for domestic manufacturing. Can't we just use steel or aluminum instead? Theoretically, yes. But switching materials comes with serious trade-offs. Steel is heavier, it slows down robots, and increases energy consumption. Aluminum is weaker, it fails under high stress. So, is the West trapped? Or are there alternative sources? Let's take a hard look at where titanium really comes from. The global titanium supply chain is a geopolitical minefield. China, Russia, and Kazakhstan together control an estimated 65% of global titanium production, according to the latest figures from the International Titanium Association. China alone accounts for 35%, with Russia supplying 25%, and Kazakhstan adding another 5%. These countries dominate not only raw material extraction, but also the high-grade titanium processing required for aerospace, robotics, and military applications. Beijing's Boeing Group, the world's largest titanium producer, supplies an overwhelming share of titanium sponge, a critical raw form of the metal, exported to Western nations. The United States, in contrast, produces less than 5% of the global supply and remains entirely dependent on imports, with the Pentagon alone sourcing 85% of its titanium needs from foreign suppliers. The looming question: if China enacts a ban, where does the West turn? The options are scarce, and each comes with steep costs or geopolitical entanglements that make a quick pivot nearly impossible. Japan's titanium industry, led by Toho Titanium and Osaka Titanium Technologies, is among the most advanced globally, producing roughly 15% of the world's high-purity titanium sponge. However, while Japan is a leader in titanium processing, it still depends on China and Russia for a significant portion of its raw materials, creating a supply bottleneck that Western nations cannot simply bypass. According to the Japan Titanium Society, Japan's production output has remained relatively stable at around 40,000 metric tons annually, compared to China's 210,000 metric tons. A shift to Japanese supply would cause price surges of up to 40%, making titanium-intensive industries like aerospace and robotics financially unsustainable. Moreover, Japan's firms are deeply integrated into the Chinese supply chain, meaning that if Beijing cuts exports, Japanese suppliers could also face disruptions, either due to shortages or indirect pressure from Chinese regulators. In essence, Japan isn't a replacement. It's another vulnerable link in the titanium crisis. Mozambique, South Africa, and Kenya hold some of the world's largest untapped titanium reserves, particularly in the form of ilmenite ore, a primary titanium source. However, these regions offer no real escape from China's dominance, as Beijing has spent the last decade securing exclusive mining rights across Africa through Belt and Road Initiative investments. Chinese firms, including China National Nuclear Corporation, CNNC, and Lomon Billions Group, now operate over 70% of Mozambique's titanium mining projects, according to African Business Magazine. The Moma titanium mine, Africa's largest, exports nearly 90% of its output to China, which is then refined and processed into aerospace-grade titanium. Western companies like Tronox Holdings and Kenmare Resources have operations in these regions, but their output is insufficient to offset a Chinese export ban. Effectively, even if the West shifts supply chains to Africa, China's control over refining capacity ensures that raw titanium remains locked within Beijing's sphere of influence. Titanium's unique combination of strength, lightweight properties, and corrosion resistance makes it irreplaceable in robotic manufacturing, particularly for high-performance industrial robots, AI-driven automation, and surgical robotic arms. Alternative materials like steel and aluminum pose serious drawbacks. Steel is too heavy, reducing energy efficiency and speed, while aluminum lacks the required durability, leading to increased maintenance costs. Carbon fiber composites have been explored, but they lack titanium's heat resistance and are significantly more expensive to produce at scale. According to the International Federation of Robotics, global industrial robot sales hit 553,000 units in 2023, a 5% increase year over year, with China leading the market at 52% of total installations. A titanium ban would cripple Western automation ambitions, driving up production costs and forcing manufacturers to redesign entire robotic architectures, an effort that could take years and cost billions in R&D. At present, there is no viable substitute that maintains both the cost-effectiveness and performance of titanium, making China's potential export restriction a direct threat to the future of Western automation. China has long pursued vertical integration in the robotics supply chain, controlling everything from rare earth minerals to semiconductor production. Titanium is the final missing piece in Beijing's technological dominance strategy. The Made in China 2025 plan, which aims to make China the global leader in AI, robotics, and industrial automation, has already funneled over $150 billion into domestic manufacturing subsidies. According to China's Ministry of Industry and Information Technology, Chinese companies, including Seasun Robot and Automation and DJI, are aggressively expanding robotics production capacity, with plans to quadruple output by 2030. By restricting titanium exports, China doesn't just weaken Western competitors. It forces foreign robotics firms to establish production facilities in China, effectively transferring intellectual property and technology leadership to Beijing. The West's dependence on Chinese robotics exports has already reached a critical threshold, with companies like ABB, KUKA, and Yaskawa increasingly integrating China-manufactured components into their systems. If China pulls the trigger on a titanium ban, it won't just disrupt supply chains, it will dictate the future of the robotics industry itself. Despite Western sanctions on Russian titanium, companies like Airbus, Boeing, and Rolls-Royce continue quietly securing supply through third-party nations, particularly via India, Turkey, and the UAE. Russian titanium giant VSMPO Avisma, which supplies 1/3 of global aerospace-grade titanium, has found workarounds through re-export agreements, effectively sidestepping sanctions. Airbus CEO Guillaume Faury has openly lobbied the EU against expanding titanium restrictions, warning that cutting off Russian titanium could lead to a production crisis worse than the chip shortage. The aerospace industry's dependency on titanium is so severe that Boeing, after initially halting Russian titanium purchases in 2022, has reportedly sought alternative routes through Southeast Asian intermediaries, according to Reuters. The reality is simple. Western aerospace giants cannot afford to abandon Russian titanium, making China's potential ban even more dangerous. Because if both Moscow and Beijing cut exports, there is no alternative supply large enough to prevent an industry-wide collapse. Recycling titanium is technically possible, but economically impractical at scale. Unlike aluminum or steel, titanium requires high-purity processing, and only 5% of titanium scrap is currently recycled globally, according to the Titanium Metals Corporation. The United States and Europe lack the infrastructure to process recycled titanium in meaningful quantities, with only a handful of facilities capable of refining aerospace-grade material. The Pentagon has pushed for increased titanium stockpiling, but current reserves would only last 12 to 18 months in a crisis scenario, far below what's needed for long-term supply stability. A strategic shift towards stockpiling should have started years ago, but now, with a potential Chinese export ban looming, industry leaders fear that the window for preparation has already closed. Aerospace and defense will bear the brunt of a titanium crisis, with aviation facing crippling delays and cost surges. Airbus and Boeing, the two largest commercial aircraft manufacturers, source over 50% of their titanium from China and Russia, according to industry estimates. Boeing's 787 Dreamliner alone contains over 14 metric tons of titanium, used in airframes, landing gear, and critical engine components. Any disruption in supply could add billions in extra costs and stall production timelines by up to 5 years, based on projections from the European Aerospace Industry Association. Defense contractors are equally vulnerable. Lockheed Martin's F-35 fighter jet, a cornerstone of U.S. air superiority, is composed of 40% titanium by weight. Pentagon insiders warn that without a stable supply, jet production could drop by 30% within 2 years, significantly weakening NATO's long-term military capabilities. The U.S. Department of Defense currently imports 85% of its titanium, making it highly exposed to any strategic export bans from Beijing or Moscow. While construction also relies on titanium, particularly in high-performance alloys for bridges, skyscrapers, and industrial equipment, the impact will be less catastrophic. The Global Construction Review reports that shifting to alternatives like high-strength steel or aluminum could increase material costs by 20 to 30%, forcing developers to either absorb higher expenses or delay projects altogether. However, in sectors like nuclear power plant construction, where titanium is used in corrosion-resistant piping and cooling systems, finding substitutes will be far more complex. Analysts from Wood Mackenzie caution that a prolonged supply crunch could increase global infrastructure costs by $10 billion annually. Though the most immediate threat remains in aviation and defense, where titanium is simply irreplaceable. The West faces a now or never moment to secure its titanium supply chain, but options are limited and costly. Washington is already exploring domestic mining projects in Utah and Colorado, but regulatory hurdles and environmental concerns mean it could take over a decade to develop these reserves. The European Union is scrambling to secure titanium trade agreements with India and Brazil, but these efforts remain largely in early stages. At this point, strategic alliances with Japan and Australia remain the most realistic short-term solutions, though they fail to fully offset a Chinese ban. Meanwhile, China is tightening its grip, and if Beijing enforces export controls, Western industries will be caught in a supply chain crisis with no quick fix. Titanium isn't just a commodity, it's a power play in the fight for technological and industrial dominance. The West is running out of options, and unless urgent action is taken, China will dictate the future of robotics, aerospace, and defense. We're glad you're enjoying this video. Please like and subscribe. Check out another video that is now on your screen.